So in this video we're going to discuss regarding integration testing. Okay, what is exactly integration testing and all, right? So integration testing, as you can see here, we already observed the introduction to integration testing and all, right? Integration testing is nothing but units are there, right? So we're going to take up all the units and using the interfaces we're going to club those different models. So based on that one, after integrating more than integrating different models, we're going to conduct test whether the integrated models works or not. Okay, this is simple and appreciate to conduct the integration testing, and a simple way to conduct the integration testing, right? So under that integration testing, the main thing here we are going to see is the approaches to the integration testing. What are the main approaches, different approaches? The first approach is functional decomposition. This is actually the most commonly described in literature. Second approach is call graph, and third approach is through paths. Okay, these are all different approaches. In this approach, we are going to conduct the integration testing. So this is the last chapter of your model 5 model. So when you finish the integration, all model 5 will be over. Okay, so this is also one of the important concepts. They will ask most, you know uh, they will ask questions from this in these portions also, this chapter also, like what are the different approaches of integration testing and all. Or they will ask, explain the calligraph method, or explain the path based method and all, right? So coming to the functional decomposition approach, we have top down approach, bottom up approach, system sandwich approach, big bang approach. So in these approaches we already encountered, right? When we are actually you know talking about the introduction to integration testing, this approach we already encountered. So this approach again we will going to face these approaches with an example, with different examples, right? So these are all based on taking the example of a SATM system. Okay. So before going to look up what exactly the different approaches and all, here we should know the closer look of SATM system. So we will take this simple automated teller machine to example, give example to this integration testing. Okay. So the decomposition is the basis for usual way of integration testing. Okay, a complete unit is there. We're going to decompose that unit into different simple parts. It is important to remember that such a decomposition is primarily a package partition of the system, right? So as software design moves into more detail, the added information let us refine the functional decomposition tree into unit calling graph, right? So when we further when we go further during the software design process, this added information actually refine the functional decomposition tree. So they will actually refine this functional decomposition tree into unit calling graph. What exactly that unit calling graph we are going to see in the upcoming slides. Okay, this point you need to remember when we actually goes further in the system design process. This functional decomposition actually refined into unit calling graph. This unit calling graph is the directed graph. Okay, of course, the explanation regarding this one will be available in the next slides. But what exactly this one? The unit calling graph is the directed graph in which nodes are program units. Okay, nodes are nothing but program units, and edges corresponds to program calls. Okay, so unit calling graph is nothing but a directed graph. Unit calling graph, nothing but a directed graph. Directed graph in the sense a graph is there with some direction of flow, right? simple assume, right? Just assume in the model 3 we have a DD path, DU path and all, right? In that program graph we have some certain direction. In those direction the program control will show. That is called directed graph. Same way, this unit calling graph is nothing but a directed graph in which nodes are nothing but the program units. The program units is called nodes, and the edges actually corresponds to calls, program calls. So if there is a connection between node A to node B, like A is there, just assume node A is there is a line between A and B. I mean there is a connection between A and B. This A and B is nothing but program unit. The line, the connection is nothing but call. It means that A is actually calling the unit B. Okay, this is the meaning of unit calling graph. Okay, so that's what they have actually telling you here. Correspond to program, that is if unit A calls unit B, there is a directed edge from node A to node B. Okay, so when you are actually writing about the closer look at SATM system, you people should mention what exactly the unit calling graph and all, right? Here some units are there in SATM, units and abbreviation names are there. For example, unit number they have mentioned here. One is the first unit, that is actually SATM system. Okay, so 1.1, the function decomposition, one is actually decomposed into different parts, right? 1.1, under 1.1, 1.11 is there, under 1.111 and another 1.1.1.1 is there, different decomposition. SATM system is decomposed into device sense and control. Under the device sense and control we have door sense and control. Under door sense and control we have get door status. Okay, so under door sense control we have actually three unit. One is get door status, control door and dispense cache. Okay, 3 is 4, that's why 1.1.1.1 to 1.1.1.3. So after that one, again 1.1.2 will come. Here slot sense and control will be there. Under slot sense and control we have actually 5 unit: watch card slot, get deposit slot, control card, control level proler and all. So in this way we have different units, right? So here the different units are level number is there, unit number is there. So unit number in the sense the number, okay, different units number 180, 2, 3, 4 up to C, to 27, right? This is actually functional decomposition. Whatever we actually encounter, this is actually functional decomposition of that unit. One is divided into A, 10, B, C and all, right? Again C is again decomposed into different units. This is a functional decomposition graph. Okay. Here the first approach is under the decomposition based thing, decomposition based integrations, right? We have different integration, right? Decomposition based integration like top down approach, bottom up approach, big bang approach, sandwich approach. So when because this is one of the important question, explain different decomposition integration strategy. So you need to explain top down, bottom up, sandwich and big bang. Okay, there are actually 4 choices, right? What I actually told you, from top to downward, top down, from bottom to tree upward, bottom up, some combination of this sandwich, and most graphically none of this, means none of the 3 approach, big bang. Okay, all of this integration orders presume that units have been separately tested. Thus the goal of decomposition based integration is to test the interface among separately tested units. So here the main thing is nothing but what is the main thing here? When you are actually ordering this thing, so different units actually has different manner. Okay, different units, like different units are there, different models. Each models are very separately tested. Okay, separately tested, and then they will undergo integration testing. Okay, let us discuss one by one what exactly this top down integration mechanism is. So it is based on BFS, right? Bit per first traversal of a function decomposition tree. So first here we are going to check the main program logic, top, right? Top is nothing but the main program. With all call units replaced by stubs that always return correct values. What is this stubs, right? So if you don't know what the meaning of drivers, stubs and all, then you can't clearly understand these concepts. These stubs are actually considered as a dummy program unit. Okay, when before replacing that actual code, we will first test this with the dummy program unit that is actually calls the main program. That's why here just check the next point here. So a main program is there with all called units replaced by stubs that always return correct values. Move down one level. Replace one stub at a time with actual code. First we will check with the stubs. Okay. Once the check is over, once the check is successful, we will going to replace that dummy unit. Stub is nothing but the dummy code with the actual code, and again we are going to check. So in this way, stubs is nothing but the dummy parts. Okay. If any fault must be in the newly integrated unit test, then we can easily detect those faults. Okay. This is the way of checking the top down one by one level, top down approach. Okay, bottom up approach, what actually we are going to do here, reverse of top down integration. So we always start with leaves of the functional decomposition tree, leaves in the sense from bottom. So in the top down we will start from program main program. For bottom approach we will start from the lower level program, lower level unit like leaves. So here instead of stubs we are going to use drivers. In top down we are going to use stubs. In bottom up we are going to use driver. What exactly driver unit is? It calls next level unit. Okay, the driver always calls the next level unit. Serves as a small test bed. Okay, small test unit. Drive the unit with inputs. Drivers now expected outputs. Okay, to drive the process into the next level, we are going to use the drivers and all. So it will always calls the next level unit. Okay, as with top down integration, one driver unit at a time as replaced with the actual code. So in top down integration, what actually we are doing, we are actually replacing the stub with the one unit at a time. In a bottom up approach, we are going to replace driver. Driver is also considered as a dummy piece, dummy code for testing purpose. That's why it is called test bed. Okay, at each level we are going to replace one driver at a time. So if any fault is there, the newly integrated code, it will be most likely be detected. Okay, as for regarding that one, this approach, like the code approach SRTM system, if you want to explain again, the same explanation is also comes here with a in the form of a sentence. Top down integration begins with main program, of course. Any lower level unit that is called by the main program appears as a stub, right? Where stubs are pieces of throwaway code that emulate a called unit. So main program is there. Main program actually called by different units, right? So instead of using the different sub function, in the place of sub function, this dummy code stubs will be used. Same approach. Coming to a SATM system, regarding the SATM system, the first step would be to develop stuff for all the units called by the main program. So here watch card slot will come, card control card roller is there, screen driver, validate card, validate pin, manage transaction, and new transaction request. These are all actually then generally testers have developed the stubs. These are all actually considered as stubs, and some integration is required here. Here another two examples for stubs here. Let's look at here a procedure get pin for pan. Okay, this is actually function, procedure function. Follow accept two integer pan expected pin two a parameter pan and expected pin. This is one step. Another step is key sensor. First one is get pin for pan. Second step is key sensor, right? So in this step actually what exactly it's doing, If pan is 1123, then pin will be arranged as 8876. If it is 1234, the pin is equalized as 8764. If pan is 8746, then pin is assigned with the 1253 number. So get pin fair pan. According to pan, the pin will be uh, actually uh, pin will be actually returned. Okay, regarding the key sensor stub, whatever key you actually press in the stack of keystrokes, for example 887 cancel and key it will be popped out. Okay, that's why regarding keystrokes, okay, regarding keypad, whatever you're going to press, it will be popped out. Okay, the key sensor will sense the key, pressing the key event and all. Okay, this is one example for two steps unit. Okay, so in this top-down integration approach, the step for get pin for pan, the tester replicates the table lookup with just a few values that will appear in test cases. They actually replicates the table. In that step key sensor, the tester must devise a sequence of port events that can occur once each time the key sensor procedure is called. The previous video also mentioned what exactly the port events. Whatever events actually takes place in an interface of that SATM system is considered as a port events. So the key pressing events is also port events. For example, here we provide the keystrokes to partially enter the pin 8876, but the user hit the cancel button before the fourth digit. For example, if 887 instead of pressing 8876, user may enter 887 and enter cancel button. Then the whole operation will be cancelled. Okay, all R will be recorded in the key sensor. So in practice, the effort to develop steps is usually quite significant, right? So people always remember that when you actually conducting top-down integration or decomposition based integration, like top-down integration, you need steps. If you are conducting bottom-up integration test, you need drivers. These stubs and drivers are actually the subprogram, dummy subprogram that calls the actual main program. Okay, this point people should remember. There is a good reason to consider stub code as part of software development and maintain it under consideration management, right? Of course, we need this dummy code, right? These are some example. You can just see here for top-down approach. First, we have considered the top level model, the first level actually. Second, we came for the next level, right? And third, we cover the last level, right? The first these three level, bottom level sub tree. So all are covered here. Okay, in this way, the top-down approach actually carries. Regarding the bottom-up approach, before going to bottom-up approach, we can see another another explanation or another set of statements which actually carries regarding what is actually steps for SATM and all. Once all the steps for SATM main have been provided, we test the main program as if it were a standalone unit. Once actually provided these steps, we will actually directly test the main program. We could apply any of the appropriate functional and structural techniques and look for faults. Okay. So when we are convinced that the main program logic is correct, we gradually replace stubs with actual code. Okay. Using the stubs, actually what we are actually doing, we will check whether the main program code is correct or not, whether it is working fine or not. So if it is working fine, then only we are going to replace steps with the actual code. So sometimes it becomes problematic. For example, it will contain some question, it will arise some question like something like, would you replace all the steps at once? If we did, we would have a small bank for units with high out degree. So some questions like whether we need to replace all steps at one, or one by one we can be replaced. This question maybe arises. This kind of drawbacks is also present. Okay. So if we replace one step at a time, we retest the main program once for each replaced step, right? Even though if you replace all the steps is one, it's also problem. Even though if you replace one step at a time, you need to again test main program each time you're going to replace different. For example, assume that 5 stubs are there. Okay, first you're going to replace one stub with the actual code, and you need to test that one whether it's working or fine or not. Again, second step, you need to test the second time, third time after replacing that step, fourth time, fifth time. So 5 times you need to test the main program if you replace each step one by one. So this is also some kind of problems you can arise here. That's why this means that for SITM main program example here, we would report integration testing at 8 times. Each steps are there, that way once for each replace step and once with all steps. Okay, so we need to execute 8 times. 7 steps are there, 7 each time, and 1 for replacing all step at once. Okay, total 8 times you need to conduct integration test. Regarding the bottom up approach, bottom up integration is of course mirror image, same as the top down, but it is in reverse direction. That's why it is a mirror image to the top down order, with the difference that stubs, instead of stubs we are going to use drivers here. Okay, stubs are replaced by driver modules that emulate units at the next level up in the tray. Okay, so in bottom up integration we start with the leaves of the decomposition tree. Units like control door, dispense current, and test them with special coded drivers. So instead of checking the main program here, where we are going to check main program in top down approach. In bottom up approach, from lower level we are actually travels from lower level to the higher level. So use the drivers and check the code first, whether the bottom up units are working or not. Okay, there is probably less throwaway code in drivers than there is in stubs. Okay, compared to the stubs we need to replace all the stubs here, but compared to the stub level, we need to use only a small amount of, or like small levels of, a small number of drivers are there. That's why the number of stubs, number of drivers actually throw away code, in the sense the wasted what wasted drivers, actually number of wasted drivers are actually less compared to the stubs. This is another. Most systems have a fairly high fan out near at the leaves, so in the bottom up integration we won't have a as many drivers. That is the actual reason. Okay, so during during system level, at the bottom up level the integration actually doesn't need much drivers here. Okay, this is particularly upset by the fact that the driver models will be more complicated. Okay, so of course since this is more complicated, it's better to use less models here. Okay, this is example of bottom up approach. First we will will test from the bottom first. In second diagram, second thing, third diagram, the all levels actually we covered. Okay, in this level we are going to conduct the bottom up approach here. So sandwich integration is another there. Sandwich is nothing but what sand. So in the bottom of in the sandwich approach, what actually we are going to do, we are doing is the combination of that one. Okay, sandwich integration is a combination of top down and bottom up integration. If you think about it in terms of decomposition tree, we are really just doing big bang integration and its subtree. Okay, there will be a less stub and driver. This one point you should remember, there will be actually a less driver, less stub is required and less drivers is required. Okay, less stub and driver development effort, but this will be offset to some extent by added difficulty of fault isolation, that is a consequence of big bang integration. Okay, this is a sandwich approach, combination of both approach. Just write this one like this. It's actually sandwich integration. Here we followed all the two approach, top down as well as bottom up approach. What are the pros and cons of this decomposition based integration? Advantage is nothing but it is clear, intuitively clear, uh, built with proven components. Like by using stubs and driver, we build the complete proven components, okay, built with a proven component. Fault isolation varies with the number of units being integrated. That is also one of the important thing. The fault identification is actually based with or varies with the number of units being integrated. Disadvantage is based on lexicographic inclusion, a purely structural consideration. Okay, lexicographic in the sense a purely structural consideration. Some branches in a functional decomposition may not correspond with actual interfaces. This is also one of the disadvantages. Okay, the last one is stub and driver development can be extensive. Of course, since it requires stubs and drivers, it is considered as an extra cost. Okay, these are some pros and cons of decomposition based integration. Okay, so in the next video we will just explain. I'm going to discuss regarding the another important concept called call graph based integration. So there are actually three approach. Okay, when we can when we are actually discussing integration based testing, there are actually three approach. The first approach is was decomposition based integration. Under decomposition based integration we have four approach. One is top down, bottom up, sandwich, and big bang. Big bang, in the previous video, previous slide, we just see the big bang, right? Here, you can see here. Big bang is nothing but at once we are considering all the thing. Okay, instead of step by step, we are considering all the unit as one. We will make that unit. We are going to test that one. There is no stubs and driver required in big bang. It's considered as a all at once approach. Okay, that is the thing. A small definition is only present there, big bang approach, but the main thing is top down, bottom up, and sandwich. Okay, big bang just write the definition for big bang. So another approach is call graph integration. Okay, this we're going to explain what exactly the call graph integration and in the next video. And after that one, another approach is there, that is called path based integration. Okay, so all these three is very important. Either they will ask for one of the three integration they will ask, like path based approach. They will ask path based approach or call graph based integration or decomposition based integration. So it's better to ready for all this approach. Okay, so in the next video I will complete call graph integration approach as well as path based integration approach. That will actually complete the model 5 also. Okay, later we can revision all the modules, especially the module 3. Module 3 actually some basic concepts are there, important concepts. I'm going to discuss the important concept of module 3 in the upcoming videos. Okay, thank you.